Chapter 9.4, 9.7, hyperbolas and parametric equations. So hyperbolas are very much like ellipse equations, except for one of them is negative, okay? Either x or y is going to be negative. Ellipse equations, literally the only difference is that there's a positive here, okay? Follows the same sort of rules. The only thing you need to know with this, because we used to have to like graph the whole thing, find the asymptotes that go here. All you have to know is the transverse axis, the center, and the vertices. Okay, the center, the vertices, and the transverse axis. So these are the equations. When y is negative, the transverse axis is the one that it goes like against, that goes through the vertices. Does that make sense? So the line, the horizontal or vertical, if it goes the other way, that goes through the vertices. So when y is negative, the transverse axis is parallel to the positive one, the x-axis. When y is positive, the transverse axis is parallel to the y-axis. So, looking at what we've got here. Our center. Your center is just like everything else. It goes with the x and the y. If you're adding or subtracting something to x and y before you square it, that's your center. So here we have our center is at 0, 0. Because we're not adding or subtracting, no shifts from the x squared and the y squared. Then our a value is our bigger number. The reason it's our bigger number, so it's the positive one. Whichever one is positive is bigger than a negative one. It's always the positive one. Your a value here, remember this is a squared and b squared, so a is going to be the square root of 16, which is 4. And we will use that a value to find our vertices. Your a value is the distance from the center to each vertex. So since this one is x squared and since this one is positive x squared, then our transverse axis is parallel to the x-axis, which means that it's going to look like this. Since our center is at 0, 0, this is going to be the graph of our equation. So to find our vertices, I go from our center left 4 and right 4. So my vertices will be plus and minus 4, 0, or 4, 0 and negative 4, 0. You can write that as 2 separate points. Your transverse axis is the one that's the same as your center. So from your vertex to your center point, the value that's the same, that's your transverse axis. So that's y equals 0. And we will do some graphing of these on Desmos in a few minutes. So this equation is graphed like this. 1, 2, 3, 4. We have a sort of a parabola this way. 1, 2, 3, 4. And a parabola-ish thing that way. There's my center.
So whatever like positive, whatever positive determines the vertices. Like you have the a value of this.
Whichever one, yes. The positive one determines the distance from the center to your vertices. Yes.
That's for the bottom of the
Positive one. Yes. Yes. Does that make sense? Okay. So just like when we did with ellipses, it has to say equals 1. If it doesn't say equals 1, you're going to make it say that by dividing whatever it does say it equals. So I'm going to divide this whole thing by 4. So I have y squared over 4 minus x squared, and I like to just go ahead and put the 1 there. Just it makes me, I don't know, for some reason it helps my heart. And then equals 1. So now this one, my y value is positive, so my parabola is going to look something like this. Or my hyperbola, rather. Sorry. So my center is still 0, 0. And my a value, the one that's positive, is 4, is the square root of 4, which is 2. So from my center, I'm going to go up 2 and down 2 to get to my vertices. So to go up 2 and down 2, my vertices are at 0, plus and minus 2, or 0, 2, and 0, negative 2. You can write those separately if you want. Your transverse axis is always the one that stays the same between your center and your vertices. So this would be x equals 0, the line x equals 0. When I graph these, my center's at 0, 0, up to, down to. Question so far? And then the last one. I need it to say equals 1, so I'm going to divide both sides by 36. I will simplify that fraction. 9 divided by 36 is 1/4, so I'll have x squared over 4. 4 divided by 36 is 1/9, so I have y squared over 9 equals 1. Remember, your bigger one is the positive one. So my center is still 0, 0. This one has a positive x squared, so my transverse axis goes along my x-axis, and it'll look like this. My a value here is 4 again, because that's the positive one. So the square root of 4 is 2. My vertices will be, I'm going to go left and right from my center, so plus and minus 2, 0. And my transverse axis is the one that stays the same from the center to the vertices. So this case, it's y equals 0. So my center's at 0, 0. My vertices are at positive 2, 0. And at negative 2, 0. Questions when your center is 0. We are going to look at 2 examples, one that's in general form that we'll have to convert to vertex form. Center is not at 0, 0. And then one that's already in vertex form, convert it to general form. So just like the other guys, these are the 2 that will be on your test. One's like these 2. Find the center, vertices, and transverse axis of the hyperbola, convert to vertex form. It's easiest if you start at vertex form. So I'm going to do that first. Just like before, I'm going to complete the square. So I have my negative x squared. I'm going to put my x's together. Minus 2x plus something. Put my y's together. Plus 4y squared minus 16y plus something. I'm going to move my constant over, so I'll have negative 11. And then whatever I put here, I also have to put on the other side, or it changes my equation. Questions so far? Remember, you have to pull your GCF out. You can only complete the square when your leading coefficient is positive 1. So this one has a negative, so I'm going to pull that negative out. So I have x squared plus 2x plus something. And this one, I'm going to pull out my 4, so I have y squared minus 4y plus something. And that also changes the other side. Instead of a plus out front, I'll have a minus something on that first one. And I'll have a plus 4 times something on that second one. Remember to find what goes in there. You take your b term, divide it by 2, and square it. So 2 over 2 squared. 2 over 2 is 1. 1 squared is 1. Here we have negative 4 over 2 squared. Negative 4 over 2 is negative 2. Negative 2 squared is positive 4. So now I'm going to factor. So I have negative x plus 1 squared plus 4 times y minus 2 squared equals, I have negative 12 plus 16, which is 4. I need it to say equals 1, so I'm going to divide the whole thing by 4, and I'm going to reorganize so that my positive 1 comes first. So 4 divided by 4 is 1, so I have y minus 2 squared over 1. And then I have minus x plus 1 squared over 4 equals 1. That's my vertex form. Probably the hardest part of these. So because my y is positive, it's going to look something like this. My transverse axis is going to go along with the y-axis. I like to see what it's supposed to look like. It helps me think of how to move things. So my center, it's always HK. H always goes with X. K always goes with Y. Remember to flip those signs. So your center is negative 1, 2. Your A value, remember that's the positive 1. So we have a square root of 1, which is just 1. So since our center is negative 1, 2, and our transverse axis is going to go along with our y-axis, that means our vertices will go up 1 from our center and down 1 from our center. So my vertices will be negative 1. If I go up 1 from here, it'll be negative 1, 3. If I go down 1 from there, it'll be negative 1, 1. And then my transverse axis is the one that's the same between my center and my vertices, so that's x equals negative 1. Then I'm going to graph it. Negative 1, 2 is my center. My vertices will go 1 up from that and 1 down from that. It might help you to graph it first. And then my transverse axis is this axis, x equals negative 1.
How'd you get the y value from the transverses?
On my vertices here.
Yeah,
That's okay, I was just making sure. So you take your center, and because of how it's going, because my y value is positive, I know it's going to look like this. It's going to open upward and open downward. So your A is the distance from your center to your vertex. So since it opens up and down, my A value is the distance from my center. So I'm going to go up 1 and down 1 from my center to get those vertices. Does that make sense? The next one, x minus 1 squared over 4 minus y plus 2 squared over 5 equals 1. My center is going to be 1, negative 2. My A value, my positive 1 is 4, so that's going to be the square root of 4, which is 2. This one has x squared, so because it's x squared, it's going to open right and left. Since it's going to open right and left, then I'm going to move right from my center 2 and left from my center 2. So my vertices, if I go right 2, I'm adding 2, so I have 3, negative 2. If I go left 2, I'm subtracting 2, so I have negative 1, negative 2. So from my center to go right, I'll add to my x value. To go left, I'll subtract from my x value. If you want to look at the graph first, we have the point 1, negative 2 is my center. I know it's opening this way. So to find my vertex, I'm going to go right 2 and left 2. And my graph will look like this. If it helps to draw the graph and then write out what those are, then by all means do it in that order. Your transverse axis is the one that's the same between your center and both vertices. So we have y equals -2. And that is this axis here. Now to convert this equation to standard form, it's exactly like how we did it with the hyperbola. We have to get rid of the fractions. So we're going to multiply by the least common multiple. So the least common multiple between 4 and 5 would be 20. So if I multiply the whole thing by 20, 20 divided by 4, I'll have 5 times x minus 1 squared. Minus 20 divided by 5 is 4 times y plus 2 squared. Equals 20 times 1, which is 20. Remember, you have to FOIL out your x minus 1 squared and your y plus 2 squared. So I'll leave my 5 out front. X minus 1 times x minus 1, when you simplify that, is x squared minus 2x plus 1. Y plus 2 times y plus 2, when you simplify that, is y squared plus 4y plus 4. I will then distribute my coefficients. So I have 5x squared minus 10x plus 5. Here I have to distribute both the negative and the 4. So negative 4y squared, negative 16y, negative 16. Then I'm just reorganizing. Remember, your x squared goes first, followed by your y squared, then your x, then your y, and then you put your constants together. So I have 5 minus 16, and then I also have to subtract my 20 so that it says equals 0. I have minus 31 equals 0. That is standard or general form. Any questions on parabolas, ellipses, or hyperbolas? All right, we're looking at the last part of chapter 9, which is parametric equations. Your calculator has a mode for parametric equations. So back before they changed the curriculum, we actually got to use all 4 of the modes. So we've used function. They cut out polar altogether, which stinks because I love polar. But parametric is the mode we're going to be in. When you look at this, it changes the way you put in graphs. Parametric gives us a third variable that is the same for each one. Typically, that variable is time. Okay. Typically, that variable is time. So let x equal f of t, it's a function of time, and let y equal a function of time, where these two functions whose common domain is some interval. The collection of points defined by xy is f of t at that x value and g of t. It's a plane curve. So we're going to discuss this and convert it to Cartesian or just xy form. So this equation, we have x equals 3t squared and y equals 2t squared. Our t values are from -2 to +2. We're going to create a table where our t values go from -2 to +2. So -2, -1, 0, 1, and 2. And what we're going to do is we're going to plug it into x and to y. And the way we graph this on an xy coordinate plane is by using that coordinate, xy, that's created from the t. So at -2, we're plugging it in. 3 times -2 squared. And you can just type it in your calculator. 3 times -2, whoops, squared is 12. Then I'll plug it into the y value. 2 times -2 is -4. So the ordered pair that I would graph on my xy coordinate plane would be 12, -4. That's how that would translate to a graph. Then I'll do the same thing with -1. 3 times -1 squared is 3. -1 times 2 is -2. So this ordered pair is 3, -2. 3 times 0 squared is 0. 2 times 0 is 0. So this ordered pair is 0, 0. Three times 1 squared is 3. 2 times 1 is 2. Three times 2 squared is 12. 2 times 2 is 4. So 12, 4. Then I'm going to graph these values. I have the point 12, -4. I have the point 3, -2. The point 0, 0. The point 3, 2. And the point 12, 4. Because this is only from -2 to 2, it does not continue. This is our graph. When you go to graph this in your calculator, you'll type in your x t squared, or 3t squared rather, and 2t. But then you have to look at your table set or your window. Is it your window? It's your window. Your window is how you will adjust what t values are plugged in. We want t to go from -2 to 2. So then we can look at our table and get our points. And we can look at our graph, and see our graph. And if we adjust that window so that our x goes up to, I'm going to say 15, let's see if it will stop your graph there. Questions so far? The last part is to convert it so that it's just in terms of x and y. So what you're going to do is just substitution. I'm going to take my simpler one and solve it for t. So I have y equals 2t. I'm going to get t by itself. So I divide both sides by 2. T equals either 1/2 y or y over 2. Then I'll just take that and substitute it into my other equation for t. So my equation is now just in terms of x and y. So I have x equals 3 times y over 2 squared. When you square a quotient, you square both the top and the bottom. So I have 3y squared over 4, or 3/4 y squared. That is all you need to be able to do. You can type that into Desmos. You can solve it for y and type it into your calculator under function mode. Questions? One more. For some reason, mine printed funny. And we're going to do, this is number 7. Convert it to a Cartesian equation. And this one, it was from the release test. So where it said, check out number 22 on the release test, back when we had an NC final exam, this one was almost identical to it. All right, so here, this is different. When we have sine and cosine, anytime you have a sine and cosine, you're going to use a Pythagorean identity. The Pythagorean identity is the sine squared of theta plus the cosine squared of theta equals 1. So I want to get this into that format. So what I'm going to do is I'm going to divide both sides by a first because I just want it to say sine and cosine. So I'm just going to start with the first one. So I have the cosine of t equals x over a. Then I want it to be squared, so I'm going to square both sides. When I square both sides, I'm squaring everything, the cosine, the x, and the a. So the cosine squared of t equals x squared over a squared. Then I'll do the same thing with sine. I'm going to divide both sides by a, or whatever my coefficient is. Typically, you will have a coefficient, not just a. Then I'm going to square it again. So I have the sine squared of t equals y squared over a squared. Now I can use this and set up an equation. Since this is true, then that means that these two things, the sum of these two things, also has to equal 1. So x squared over a squared plus y squared over a squared equals 1. Because this is true and these things are true, I can substitute those in. If the denominators were different, this would be an ellipse. Okay? Since my denominators are the same, I can multiply both sides by a squared. So I have x squared plus y squared equals a squared. When my denominators are the same, this is a circle with a radius of a. If your denominators are not the same, it would be an ellipse. That's how you would graph it. So I'm going to give a value. I'm going to say a is 5, and I'm going to type this into my calculator. You can't have two different values. So I'm going to say 5 times the cosine of t and 5 times the sine of t. Let's see. It's in radians mode. So my y equals my table set. So I would have to adjust my t value. A is greater than 0. My window, I would need it to go to -2 pi to 2 pi to get the whole thing, I think. There we go. The reason it's 2 pi is because it's trig, it's a unit circle, takes 2 pi to go all the way around. Questions?